a member of ITS Program Advisory Committee to the United States Department of Transportation. He has a distinguished professional career as a former chair of ITS America Board of Directors, the past president of AASHTO, and a leading figure of the other important national organization as well. His presentation is titled as Advanced Mobility Option, the Impact of the AV Automated Vehicle on Society. Mr. STEUDLE, the floor is yours.
Great. Good afternoon, everybody. Great to see you're all awake. It's great to see this many people at a pavement preservation conference want to come in and talk about technology and ITS. There's a couple of questions that I think we will get to along the way. And you'll notice that mine's talking about automated, AV, automated vehicles, and I'm going to discuss a little bit between the two. There's connected and there is automated, and we'll discuss that as we go forward. The benefits, and I think the last question was asking, why would you do this? There's been a couple that have asked, why would you do this? Why would you sign up? And it really is larger than just your individual benefits. There are societal benefits from safety, efficiency, sustainability, and frankly, this is about to change our lives in the way that we move about and the way that freight moves about. So I'm encouraged by all of you being here so that you will understand the impacts that this is going to have on the pavement preservation societies and companies as well. I'm going to skip this slide. So in the United States, there were 35,000 traffic deaths in 2015. That number rose to 37,461 in 2017. So the number went up. After decades of the number going down, it's now going back up again. Those crashes amounted to $300 billion worth of costs. The crashes caused 20% of the congestion across the country. And congestion and commuter costs are about $160 billion, or almost $1,000 per commuter based on congestion. Congestion costs 3 billion gallons of motor fuels, gasoline, 7 billion hours in traffic, and 42 hours per commuter. So when we think about a connected, automated vehicle, and we think about a network of vehicles, that's the aim. The aim is to reduce those. Each of us individually will receive benefits as well because we are involved in every one of those. When you look at just crashes, the statistics hold that 90% of all crashes have human error related to them. 90%. So the sooner we take the human out of the decision making, the faster those numbers will go down. And now I know there are many of you going, wait, I want to drive my car. You'll be able to drive your car for a while, just relax. But what we're embarking on is really a change in mobility. And you think about the areas of our society that have limited mobility today. You may have some people in your family, maybe an elderly person or a disabled person that needs somebody else to take them to the doctor or to the park or to the grocery store, or maybe to go do their favorite evening activity. Where we're at is about a change in how mobility happens. It's going to be a quickly evolving ecosystem, but it's not necessarily going to be as quick as some people are projecting it's going to be. But if you think about mobility and what it means to your family, should you have somebody that is disabled or is elderly or maybe is a teenager or younger than a teenager and you think about how they have, well, their options of moving around, it depends on which city you live in, doesn't it? It depends on what kind of public transport has been supplied. It depends if you're in an urban area or a rural area. So this era of mobility will have significant benefits as well. You heard a lot about vehicle to infrastructure and vehicle to vehicle communications. And I really want to look at this picture. We had the first two presentations were focused a lot on the far left side, on connected. Vehicle to vehicle, vehicle to infrastructure. And I've got a slide or two that will talk about that, but you've heard a lot about that, so I'm going to skip over that. And then you have automated. And automated is vehicles that can drive themselves. We're going to spend a little more time talking about what does that mean. And then you have autonomous. This is the little autonomous Google car from a number of years ago. But so this is the vehicle to vehicle. I'm going to skip over this piece because you've heard lots of it. There's a good graphic here on the right? Information flow to the car, signal, back down. We've heard lots of it. I'm going to skip over it because we've heard that. Okay, so this is automation. So these levels across the top goes from 0 to 4. Actually, there's level 5 as well. These are levels of automation, and this comes from the Society of Automotive Engineers. And we've adopted that same nomenclature. So if you think of level 0, that is any car that you bought in the last, 10 years ago. It has 0 automation in it. If you look at level 1, automatic headlights, collision imminent braking, and cruise control. Most cars that you buy on a showroom floor today have most of those features. Level 2, traffic jam assist, adaptive cruise control, and lane keeping. So it slows down. The car in front of you slows down, you slow down. Self-parking with the driver. You push a button and it parks itself. Those are level 2. Those are some examples. These are on the road today. Now you'll probably have to buy a high-end car to get the traffic jam assist. I just saw it was advertised by one of the big manufacturers just recently. But you have other pieces in there. Level 3 is collision avoidance. That means the car is going to slow down and stop instead of just alerting you. It's got automated highway features, and it's got some automated urban features, meaning adaptive cruise control. It's going to sense a lot more of what's around you. Level 4 is it will valet park itself. You get to a parking lot, and you push the button, it will go find a parking spot and park for you. Think about what that means. Highway point to point. You get on a freeway or a motorway, you push the button, you engage the system, you take your hands off and take your feet off, legally. Some of you do that anyways. Level 4 takes over the vehicle and controls you on that motorway, just on the motorway. And then you have urban point to point. This is the rideshare programs that at least we have quite a few in the United States that are testing. And those are in very specific geographic areas in a point-to-point urban area. And then level 5, which is not on here, is the futuristic pods where you get in and there is no steering wheel, there are no pedals, there is nothing that looks like a dashboard. In fact, I sat in one about 2 weeks ago at a supplier outside of Detroit that basically was a big video game. And it was, you could pull up a video game and play a video game. You could watch a concert from a radio or a music person. It was really quite amazing. Now look at the bottom, and there's the timelines. Now we're going to shift to this one. Here's the driverless vehicle feature. So this slide is actually a couple of years old. And you'll notice in the middle on the top, it says traffic jam assist, available in 2016. Didn't make it. It's actually 2018, and they're coming out with traffic jam assist. I deliberately used this old slide to show here's the progression everybody was expecting 2 years ago. So when you hear the hype that says in 2019 you will have a fully autonomous vehicle that you can ride in anywhere in the country, not going to happen. It's a ways out here. If you look on the far right side, it says full autonomous systems. That's at 2025 plus. That's what we refer to as, that's level 5. Those are autonomous vehicles in the wild, or free-range autonomous vehicles. I mean, they can go anywhere, anytime. That's a long ways away, because they need a lot of cooperation with the roadside around them. You're going to see them in urban areas. You're going to see them in ride shares first, and then you'll have the ability to purchase them for highways. So there's a number of manufacturers that have those today, where you can push the button and it will drive itself in certain conditions. Auto manufacturers are all they're pretty widely varied about what their technologies can do, and they're all their own proprietary technologies. Some are more advanced than others. And then you have some tech companies that are moving their own solutions as well. So it's about reducing congestion. So if you think about an automated vehicle that has sensors all over, in fact, I want to go back to this slide. If you look at the pictures of the cars in the middle, I neglected to talk about this. The cars in the middle, and you can see those are the sensor systems around it. So you can see as you get to level 4, look at all of those sensor systems that are around it. That's what gives it all of its intelligence. That's why a level 1 vehicle, which is what you can pretty much buy today, you can see it continues to add features. So when you get to a pure autonomous vehicle, that vehicle is going through a checklist. It says, do I have a GPS signal? Do I have a high definition map? Does my LiDAR camera, is it working? Is my machine vision working? Are my other cameras working? And are my sensors working? And then, does it have a communications to a local road network, like the 2 that we just heard? That's another connection. When it starts to check those off that it does not have those systems, it does everything that every good engineer does. It says, wait, at this point, I no longer have enough confidence that the vehicle will operate on its own and it will not move. It has to have those redundant systems so that it can continue to operate on its own. If it doesn't have those, it stops. So if you think about a world of all of these vehicles in the upper left corner, if they're all autonomous, they have their own sensors, and all they can do is sense the vehicle in front of them, and they're not connected. Remember, the first 2 presentations were about the connected piece. The vehicles will actually drive like a very cautious driver, and they will have more congestion because the spaces will get bigger, and they won't be as efficient. Where we will get the reduction in congestion and the benefits of conserving energy will be when they are connected, vehicle to vehicle infrastructure, with all of those sensors on an automated vehicle, because then they can follow closer together and have a lot more technology interaction between them. I want to shift to talk about some of the testing that's going on in Michigan in the last part of my presentation here. And in 2016, the legislature in Michigan, the governor of Michigan, signed a law that allows for full operation of automated vehicles on any road at any time without a special driver's license and without special training. Now, the fact is, you can't buy one of those vehicles today. But when you can legally drive it on any of the 122,000 miles of public roads in Michigan. Now, that legislation allowed for legal automated vehicle driving. It allowed for legal on-demand automated networks, which is a driverless Uber system. It allowed for truck platooning. Truck platooning is where they're following very close together. and they are electronically tethered, and they may be traveling at full highway speeds at 50 feet or maybe 20 meters apart. It provided for a waiver of liability of mechanics as long as they fix a system back to the original specifications and haven't tinkered with it. It created the American Center for Mobility, which I'll have a picture of in just a minute. It also created the Council on Future Mobility, which is made up of 14 mainly private sector companies. The biggest names that you will recognize is General Motors, Toyota, Ford, Fiat Chrysler, and Continental Systems, along with an insurance company, a logistics company, a trucking company, a disability community activist, and then state and local governments as well. They have been in place for about a year. They are focused on liability issues, cybersecurity issues, insurance issues, and then some pilots about advanced high-definition mapping. If I could sum up what that legislation was about, it was about removing government barriers to allow technology and companies to move forward as their technology was ready. And it removes government from having to approve every single step. At the same time, it also holds those companies 100% responsible for the vehicles, their test vehicles, on the road. There's a number of innovations and partnerships that are going on in the state of Michigan. I'm going to highlight just 3 of them. The first one, down at the bottom on the left, is a partnership with 3M. We took an interstate freeway construction zone and made it a smart construction zone. And between 3M and a company called Magna, which is a Canadian company, an auto supplier, we instrumented the signs with 2D barcodes. They look like a QR code, but they're actually a little bit different, that the machine vision could pick up. Now, what was unique is they were embedded in the sheeting of the signs so that they were invisible to the human eye. The machine could see a 2D barcode. We've established there's a communications link between them. We're actually phase 2 of that starting this year and enlarging the area around there on permanent signs so that we can see what does the machine vision do from there. The second is up at the top, a partnership with General Motors and a local county of instrumenting some traffic signals. Very similar to what you heard earlier. They're sending out signal phasing and timing, fully integrated within the vehicles that will stop the vehicle from going through a red light. That was important because that pilot caused us to change our specifications for all future traffic signals. All future traffic signals will have that technology in the state of Michigan installed when they are put in place. And then the last one is with the U.S. Army, which is their research and development arm, and that involved truck platooning of 4 military vehicle convoy. The last one revolving around a connection to this bottom left corner is an international bridge between Michigan and Ontario, Canada. And that convoy, that military convoy went across that bridge and back in complete autonomous mode. I was in the 4th vehicle, a commercial vehicle, and the driver had hands off and feet off as we crossed that international border. The only time he grabbed it was when we were in the customs plaza, so that there weren't any issues as we went through the booth. That was on the heels of another partnership with Magna and Continental, which did an international border crossing of an autonomous vehicle. Started in Detroit, went through a tunnel, came up in Windsor, Ontario, drove through Canada, went across that bridge on the lower left corner, from Canada into Michigan, and another, a total of 480 kilometers, of which 95% of it was operating in level 3 or level 4, which meant hands off. And it produced, and it went flawlessly through it. Some of you may have heard of this French company called Navia. It We were proud to have them come. This is one of their first vehicles in Michigan. This actually is a picture. It's not an artist rendition. It is operating in M-City, which is a fake city. It is a simulated site. It's 14 hectares large, 34 acres, has 35 different attributes that an autonomous vehicle would encounter along the roadway. Roundabouts, blind curves, railroad crossing, dirt roads, freeways, local roads, streets, close buildings, faraway buildings. The interesting piece with this is they've also incorporated simulation. So you can put an autonomous vehicle while this shuttle is running around there. You can also come and test. There are 14 private firms that each put in $1 million apiece to operate the facility, along with 39 other firms that had a lesser amount. But you can bring their autonomous vehicle. The first OEM that was there was Ford Motor Company. It was about 1.5 years ago. They were testing their autonomous Ford Fusion in a snowstorm at night. So it's not in sunny California. It's actually in snowy Michigan in February. So somebody asked about the paint lines. The paint lines were completely obscured. You could not see paint lines. The vehicles have to be able to respond without seeing a paint line. A paint line is another one of those check marks. But if you can't see it, you better be able to move. And in fact, the statistic is in the state of Michigan, 50% of the roads do not have a paint line because they're a local street or they're a gravel road. They will never have a paint line. So, M-City started after a pilot project that was done in 2012, which had 3,000 vehicles. Those 3,000 vehicles are still running around the Ann Arbor area. It's now, by the end of next year, will be up to 5,000 vehicles that are interacting with each other and with the infrastructure around M-City. M-City was very successful, and that spurred the next facility, which is about ready to have its grand opening next week, and that's the American Center for Mobility. The American Center for Mobility is 133 hectares, which is 330 acres. It's a 4-kilometer high-speed loop around the outside. It has a 3-level interchange. If you look at the picture in the middle on the bottom, that's 3-leveled of bridges. There's live traffic that actually goes through the middle level. That's a U.S. state route that has about 15,000 cars a day, so they can do autonomous testing above it and below it and get that interaction. It has, on the far left side, a 200-meter curved tunnel that as you go in, the highly automated vehicle sees a black hole that can't see through the tunnel, and as you come out of the tunnel, you are directly facing the morning sunrise. So it will blind all of the sensors as well. It's got a 6-lane boulevard, which is over here on the right, a full interchange, a variety of different pavement types, and then this 6-lane road, which is kind of going off to the edge of the slide here, this summer will connect into another 4-lane road, which is called the NHTSA intersection, which is what the Society of Automotive Engineers needs for doing that kind of real-time testing. This site is one of 10 in the U.S. that's designated by the U.S. Department of Transportation as an autonomous or highly automated vehicle test site. This center also has private firms involved. It's a public-private partnership, 50% private money, 50% public money. 7 firms came forward and put $5 million apiece in. Another 10 firms came forward with $1 million apiece. You'll notice in the middle, those are all academic institutions. There's an academic consortium of 15 public and private universities that are working on workforce issues, engineering and technical talent development to provide the workforce for tomorrow for all of this to go forward. And then if you look in this bottom right, off in the very top, it looks like a runway because that's where it is. It's next to an airport. It's also next to a rail line, and it's next to an interstate highway. So this has the means to expand, and with Michigan's laws, once they've done validation testing here, they can go out the front gate and turn onto an interstate or a U.S. route or a state route and have full ability to drive anywhere in the state. So with that, I think I will end and have time for a few questions.
Thank you very much. Okay, so questions? Yes, please.
Bernard Jacob from ISTA. I'm quite interested in the platooning experience that you have. Just a small remark. I'm sorry for Continental and the Michigan, but it's not the first time that the autonomous car is crossing an international border, because it was done during the ITS European Congress in Strasbourg, between Strasbourg and Kiel. But however, I am quite interesting if you...
Well, we refer to that as between states.
Yes, okay.
Remember, we're a pretty big country.
If you have a bit more information about the platooning, because we are working on this topic in Europe too, and I would be interesting to know a bit more about the experience that you have in Michigan.
Certainly.
Any other questions?
Thank you. Do you know if in the M-City or any of the other tests, have they tried an autonomous vehicle with either a traffic light that is out that should be treated as a four-way stop, or with a traffic light and flash and a policeman directing traffic?
Yes, but essentially as a one-off trial. In fact, more of that has happened at individual companies. I know of one specifically, I probably shouldn't say the name of which one it was, that has shown the exact situation you were talking about. It was a police officer in the rain at night in front of a traffic light and trying to stop a car. There's the very strong understanding that the interaction with law enforcement is one of the things that the OEMs are working on. It's what they refer to as edge cases. If you think about that, so think about being on a motorway, a freeway, and a bridge is out. Maybe you have one in Georgia, right? And all the cars are backed up on the freeway. How does the police officer tell an automated car to turn around and go the wrong way on the freeway? It's not programmed to do that. So the police officer has to know how to interact, and that's one of the things they're working on yet. It's an edge case, because if the car doesn't know what to do, it's not going to, the whole system's going to break apart. There's a whole bunch on law enforcement side that's why I say fully automated is a ways away, because there's a lot of those pieces that have to be solved yet.
Thank you.
So much of this seems to be driven by
Who's asked?
DOT.
Oh, there you are. Thank you.
I'm sorry.
Okay.
So much of this is driven by DOT programs and I guess engineering firms on one side and the academia on the other. What kind of consumer demand exists for a product like this?
So actually, none of this is done by US DOT. This is done by private firms responding to consumer demand. So the pieces that I just showed you, particularly the last two test flights, have no federal money involved in it at all. So the consumer demand is responding is pushing, because that's what auto companies are listening to their customers. That's what they want to sell. This is not coming from government. This is private companies saying, we're developing these.
Okay.
Yes.
Thank you. Oh, Eric.
Yeah, a practical question about your testing site. Actually, we are trying to build such testing sites in France too. And one problem we are facing is that when you build such a testing site, well, it's brand new. So how can you simulate worn-out lane markings, for example, or worn-out pavements? Do you have solutions for that?
Well, one of the ways that we do that is we allow them to go on public roads. So you can turn off the gate and you can go find organic potholes, and you can find organic pavement markings that are not up to snuff.
Okay, thank you.
Thank you. So, one question from me.
All right, you get the
Okay.
question.
Yeah, probably everybody knows that the Uber accident last week. Yes, and it is, of course, unfortunate. What kind of impact will the accident have on the ongoing development and testing on AV, particularly in the United States?
So the impact to testing across the country is varied, and it's by companies. The one thing to remember about all of these automated vehicle companies, whether it's a tech company or auto company, is they have different technology. So the technology that Uber is using is different than Waymo, Google. It's different than Ford. It's different than General Motors. It's different than Toyota. So you can't say that, well, because the Uber one failed, the rest are going to fail as well. Because unless you know the technical specs of what exactly they're looking at, it is very impossible to do that. Now, as I've talked to a number of engineers in this particular field, the hardest thing to differentiate is a pedestrian on the side of a road, because you don't know what that pedestrian is going to do, particularly if you're moving and they're moving. They said that's the hardest piece. If you assume every pedestrian is going to step in front of you, then you'll never go anywhere. So they have to make the decisions based on very small movements as to whether this person is coming in or going out. Part of that is they narrow the vision of the radar when they're in an area where they're not expecting cross traffic. So they bring the radar in a bit, so they take some of this noise out that's over here. And then when they get to a crossing, like a crosswalk, it goes very wide because they pick up everything. So I have no idea what Uber's technology is. I don't know if that had anything to do with it. I do know that a very close friend of mine that is involved in the radar piece had told me actually well before this crash of that's how they have to take care of some of the noise that all of the LiDARs are spinning out. So I know I didn't answer your question directly because I don't know the specifics of Uber, and frankly, anybody that is speculating is just speculating until they have the data. I can tell you this, for this crash, there will be more data available than any other crash in the entire world, because you don't have to rely on asking the driver, what did they see and what did they do? Now you ask the computer. You will know exactly what the inputs were and what the actions were following it. So it will actually be more accurate in the police report than just a human driver interacting. Mr. Chairman, I think I'm out of time and I'm taking time from you others.
Okay.
Thank you.
Okay.